All right, so funny story. It turns out that this worksheet is on the back of the allowance problem. Um, so I accidentally ordered 50 copies of this when I already had 50 copies of it. But it's that's math department's budget. I'm in good shape. All right. So the Dutch auction problem. I don't know why it's Dutch, but I'm sure it's a respectful reason. So I plan to sell an old video camera on Marketplace. Plan to start by asking for $300. Each week it doesn't sell, I plan to reduce the price in order to make a sale. All right. So option one, we're going to start at 300 and drop the price $10 each week. The goal is that at some point, someone is going to buy it, and we're going to want to make as much money as we can from selling this. So start at 300, drop the price $10 each week. So I'm going to go in, I'm just going to fill in the weeks here. One, two, and I'm going to go ahead and take a little initiative and fill them in over here too. All righty. So we start at $300 and we drop the price $10 each week. So first week doesn't sell, going to drop the price down to $290. Second week doesn't sell, drop the price down to $280. Third week doesn't sell, $270. Fourth week, $260. And hopefully you can see the pattern as I fill in the rest of the table. All right, so starting out here, and I'm going to go ahead and plot this equation. So we're going to go again. X is going to be the unit of time, so it's always going to be weeks. So X is weeks, so it's always going to be the unit of time. There we go. I'll get it right eventually. And this is going to be our money. So what I'm going to do is I'm going to put this at 300, 80, 70, 2. I'll put this at 200. 1, 2, 3, 4, 100. I defined these badly, but well. All right, so start with 1 at 300. Start week 0 at 300. Week 1, so this is 1, 2, 3, so it'd be 290, 280, just shy of 75, 60, and 250, and then I'm just going to go ahead and there we go. And so what you see, despite the and it's the line is supposed to be a straight line. I just labeled the graph badly, and I just labeled the graph badly. There we go. Get it centered up. I just labeled the graph badly, and I put the points in the wrong spots. But the important thing is that you can see a general trend, that it is a straight line going all the way down. So let's start with what our equation is. So f of x equals um, plus 300. We're starting at 300, so that's going to be our y-intercept. So when x equals 0, y equals 300, so plus 300. And if we know we're dropping at $10, so it's dropping $10 every week, that means that it's going to be negative 10x. Negative 10x plus 300. Now here's the thing. The way that this line is going, it's going all the way down, and it is not stopping. Eventually, it's going to equal 0. And at that point, I'm just going to write down what that point is. When x equals 30, f of x equals 0. Because negative 10 times negative 30 is going to give you negative 300 plus 300, f of x equals 0. So at 30 weeks, you're giving it away. That's a key detail. That's a key detail I'm going to point out. So let's move over here. We start at 300 and drop the price 10% each week. So what does that mean? So it means 300, I'm going to take off 10%. Times 0.3. That gives me 210. Does it? So I'm looking at my calculator here. 300 minus 300 times 0.1. Oh, that's right. There we go. That makes more sense. 270. All right. So to solve for this, what I did was I did 300 minus 300 times 0.1. So I took 300. So I took 300 times 0.1. That's about 300 times 0.1. That's 10%. So whatever this number is, which it happens to be 30, if I multiply it by 10, that gives me 300. So that's the idea, is that it drops 10%. And the easy way to remember it is that whatever the number is that you're looking at, you're basically just taking there's an implied decimal right here. You're taking the decimal, just moving it one location over. Wait, I'm looking at the big screen when I should be looking at the paper. When you're looking at taking 10% of something, you just move the decimal over one spot, and then whatever this new number is, that's 10%. You can also work through, like I said, with the calculator. You just take the value of whatever it is, so 300 times 0.1, that's going to give you 30, and then you do 300 minus 30, that's going to give you a 270. So that's how I solved it for this first step. And so I'm going to need you all to work with me on this as I go through the next couple steps. So week 2, a drop at 10%. Does that mean that the value is now 240? No, it does not. It does not mean that the value is 240, because 240 would be if I took 30 off again. I'm not taking 30 off, because 30 is not 10% of this. I'm taking 27 off of this, because 27 is 10% of 270. So week 2, 270 minus 27. Week 2, this, I'm dropping the price to 243. So what does that mean for week 3? Week 3, I'm dropping it off by $24.3, which means this price is 218.7. So $218.70. If this were a real marketplace, I'd probably just round up to the dollar, but you know what? We're sticking with the math. We're going to stick with the math as it appears. So week 4 minus 218.7 times 0.1. That brings it down to 196.83. So week 5 minus 196.83 times 0.1. Ooh, not 0.11. That brings it down to 177. 0.147, but in this case, I'm just going to round it up to 0.15. Minus 177.1515 times 0.1 equals 159.43. All right, so 159.43. And I know it's exciting listening to me use the calculator, but hopefully you're doing this along with me. Minus 159.43 times 0.1 equals 143.49. And if you take a look at these numbers, something should be a pattern should be forming pretty clearly for you right now as I fill in the last couple spaces. 143.49 times 1. 116.2 times 0.1, 104.60. So here's the thing. Here's the thing about you doing the dropping at 10% each week. You can take a look. Let's take 300. So we have 300 minus 270. That's going to be a difference of 30, right? I mean, because that's what we calculated. But what's 270 minus 243? That's 27. All right. So what's 243 minus 218, 25. So 218 minus 196, 22. So we went from 30 to all the way down here, we're losing 22. So the pattern is that even though we're cutting the price, even though the number is getting smaller and smaller and smaller, the number is objectively getting smaller, it's getting smaller at a smaller rate. So over here, this is getting smaller at a constant rate. Not only is it getting smaller at a constant rate, but it's getting smaller at a constant rate to the point that at week 30, you're going to be giving it away for free, and presumably at 31, you're not going to be giving money to someone to take it. I mean, at that point, I would just hope that you'd be throwing it away. But let's take a look. We're going to chart this out. So I've got my X, I've got my money. I'm going to start with 300, and I'm going to set this one equal to 200. I'm going to set this one equal to 100. 100. I'm not sure if that's symmetrical. Wait a second. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Wow. All right then. Just kind of eyeballed that one. So week 0, we're 300. So week 1, we're at about 270. So I'll say it's about here. Because they're like 7 intervals, I eyeballed it really well, but I didn't eyeball it nearly well enough. So 300, so 240, so 270. I'm going to say, so 275 would be around here. I'm going to say 270 would be here. Week 3, 243 would probably be about here. Week 4, 218, I'd probably put it right about here. Week 5, 196, 177, that'd be about here. Then 159, right about here. Then 143, just a little bit under halfway. 129, a little bit over a quarter of the way. 116, most of the way down there. Then 104, just a little over, just a little bit. But here's the thing. Looking at this line, and I'm going to move it down to the picture here. If I drew a straight line between these 2 points, I get one that looks like this. But if I drew a straight line between the next 2 points, I would get a different line. Similarly, if I drew a line between these 2 points, I'd get this. If I drew a line between these 2 points, I would get this. And at this point, my skill at artistry would probably create a negligible change. But as time is increasing, the rate of change is decreasing. It's getting flatter. And what that means is that at some point, there are going to be 2 points somewhere down the line. They're going to be right here. I'm guessing. They're going to be right here and here. And the difference between them is going to be so negligible that it's almost a straight line. Difference is going to be so negligible, it's going to be almost a straight line. When you get to that point, that's what's called the asymptote. The asymptote is a value that that a decay formula will approach but never actually get to. And the best way to see what the asymptote is if you the best way to see what the asymptote is to basically just take your equation, whatever the equation is, and put in a huge number. Just put in whatever number you want, and it will get you very, very close to a particular number, but it'll be just a little over it. So say the asymptote for this is 50. I don't know what it is yet, but say that it's 50. Whatever the equation is, if I put in X and I put it into 500, then the result would be 50.000000, like a whole bunch of zeros, and then like 814 or whatever the number is. But there would always be a value there, but it would just not quite get to that value. It would never quite get to that final number. So let's see if we can figure out what the equation is. So so we have a starting value. We have an initial value of 300. So we know this is going to equal 300. And we know whatever this number is, if it's raised to the 0 power, and we know whatever this number is, it's going to be raised to the x power. Let's not beat around the bush. whatever this factor is in here, whatever is inside this parentheses, if you raise it to the x power, you set x equal to 0, you're going to get 300, which is where we start. That's where we want to be. There we go. That's where we want to be. So the question is, what do we put here? So if you remember when I talked about this, anytime you have growth, you're increasing something. If you have no growth, all right, back up a little bit. Let me straighten my thoughts out. If you have no growth, if you have no change, then the number you're going to put in here is going to be 1.0. Because no matter how much time changes, x is just an exponent for how many times you multiply this together. If you have x to the 50, you can have x to the 500th. If you multiply 1 times itself 500 times, you're still only going to get 1. So if it's growth, then the value is going to be greater than 1. Because if you get if you increase something by 10%, you're not going to put 10% here. You're not going to put 0.1% here. Because that would, you're just not going to. You're not going to put 10% here for 0.1. If you want it to grow by 10%, you have to make sure that you have that 1 that's always going to be there, and then you would just do 1.1. That 0.1 is going to be the 10% growth. Now that's if you wanted it to grow 10%. So you take whatever neutral is, so neutral is 1, and you would add 0.1, which would give you the 10%. If you want something to decrease by 10% over time, what you're going to do is you're going to put 0.9. Because what does that mean? That means that if x equals 1, whatever, so this axis here, this y-axis here, this is how much we're selling the camcorder for. This is how much we're selling the video camera for. So whatever this price is, so whatever the equation is, at x equals 1, it has to reflect that we've had a 10% price decrease. So if we take a look, 300 times 0.9 to the x, and we let x equal 1, that means 300 times 0.9, which I'm going to pull out my calculator just to be 100%. That means if x equals 1, then that means that our price is going to equal 270. Well, x equals 1, price equals 270. I'm convinced. Now, like I mentioned earlier, the thing about exponential equations like this with exponential decay is that they will approach a value, but they will never get to it. That's what's called the asymptote. And the way that you check for the asymptote is you put an absurdly large number in for x, and whatever that number is, it'll be your calculator will probably just round to it, and then that'll round down to it, and that'll be it. But remember earlier, I mentioned that at x equals 30, you're selling this thing for free. You're basically giving this away for free to someone who just wants to take up space in their house. So let's feed in x equals 30 to this equation. Let's feed in x equals 30 to this, and let's see what the price is. We'll do f of x equals, and then we'll let f of 30. There we go. And we'll see what happens when we wait 30 weeks. Because if we wait 30 weeks, dropping the price linearly, we're giving it away. So what happens if it's 30 weeks the other way? So 0.9 to the, 0.9 to the, I said 30, right? Yeah, 30 power. 0.9 xy 30 equals 0.04. All right, times 300 equals 12.72. So at f equals 30, we get 12.72. That's a 10% reduction over 30 weeks. We're finally getting down to $12. The asymptote in this case, because it's a decay, the asymptote is always going to be 0. Because no matter how far we drop, no matter how close we get, we are never going to, if we take 90% of a previous number, we are going to approach 0, but we're never going to get there. So the asymptote in this case, as shown by the calculator, is going to be 0. That's an important concept to keep in mind. But even more important is the fact that no matter how long we wait using this option where we drop the price 10%, no matter how long we wait, we are always going to sell this for money. Whereas, like I said, when we go here for option one, we're basically giving it away at x equals 30. All right, I'm going to move on to the next problem, but hopefully this is also giving you more of an exposure to what exponential equations look like and what they do.